Hello guys, very quickly I'm going to be learning everything about Chart's law. Oh yes. So what is it about Chart's law that we should know? What should we pay attention to regarding Jamb And Waec? This is our lesson 3. So follow me, let's look at it together. First, there's this lovely guy that brought Chart's law to us, and his name is Jacques Charles. I know a lot of you will say the guy's name is Jacques. It's not Jacques or Jacques. Yeah. What is his name? Jacques Charles. Are you getting it now? And don't forget this, that in 1787, Jacques Charles stated what we refer to as your Chart's law. And the question is, what is Chart's law? Very simple. Chart's law states that the volume of a given mass of a gas, what does it state? Volume of a given mass of a gas is directly proportional to the absolute temperature. In what? In Kelvin, provided pressure remains constant. Now, very simple. Just remember this. Volume is directly proportional to what? Temperature. Absolute temperature. Not just anyhow temperature. Which type of temperature? Absolute what? Temperature. Because absolute temperature is in what? In Kelvin. So if they give you a question in degrees Celsius, you must convert it to what? Kelvin. Provided what is constant there, pressure remain constant. For the last time, what's Chart's law? Chart's law states that the volume of a given mass of gas is directly proportional to what? Absolute temperature in Kelvin, provided pressure remains what? Constant. If you get that very quickly with me, and you are very sure, let's rock this together. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons. You have access to your notes. You have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. Look at this question that was brought. Waec 2013 question 22. Waec question all the way. The question says, the gas law that describes the relationship between volume and temperature, the volume of a fixed mass of gas, what did he say? Is directly proportional to the absolute temperature in Kelvin, provided pressure is constant. So, which law is that? Option A says is Boyle's law, B says it is Chart's law, C says it is your Dalton's law, and then D says it is your Graham's law. What is the answer? Of course, that's your Chart's law. Option B is the correct answer. What does Chart's law state? Volume is directly proportional to what? Absolute temperature in what? Kelvin, provided what? Pressure is what? Constant. If you get that very quickly with me. Now, what's the relationship between volume and temperature as stated by Charles? Very simple. The relationship between volume and temperature, according to Charles, is that what? Volume is directly proportional to what? Temperature. And if volume is directly proportional to temperature, what does it mean? It simply means that as volume is what? Increasing, because they are directly proportional to each other, what will happen to temperature? Temperature will also what? Increase. Simple. Because your volume is directly proportional to temperature, as volume decreases, what will happen to temperature? Temperature will also what? Decrease. That's why they are direct proportionality. Unlike your Boyle's law, where volume is inversely proportional to your what? Your pressure. That as volume is increasing, pressure is decreasing. Or as pressure is increasing, volume is decreasing. No, Chart's law is not like that. They are direct proportionality. That means if volume increase small, temperature will increase small. If volume decrease small, temperature will decrease small. Or if temperature increase small, volume will increase small. If volume increase largely, temperature will also what? Increase largely. That's your what? Your Chart's law for you. If you get that very quickly with me, I'd like you not to forget this question that was brought in Waec 2009 question 22. The question all the way says, which of the following expressions correctly represent Chart's law? Which of them? Option A says your PV is equals to K. Okay? Option B says your 1 all over root P. There's nothing like root there. First, that guy is already totally out of the way. Option C says PV is equals to nRT. That's your ideal gas equation. So this guy cannot be the answer. That's ideal gas. Option D says V is equals to what? KT. Now, the question is, what does Charles' law even state? Charles' law does not relate pressure and volume. So option A cannot be the answer. No. Charles' law is focused on volume and temperature, where it states that your volume is directly proportional to temperature. That means if volume is directly proportional to temperature, it means I can remove proportionality sign and bring in constant. That means your V will be equal to what? Your KT. And where is V is equals to KT in the option? Option what? D. Hooray, is the answer. And because D is the answer, what does that mean? Charles' law. Volume is directly proportional to temperature. If you bring in your constant K, that means your V is equals to what? KT. Simple. If you get this very quickly with me, another interesting thing is the mathematical expression of Charles' law. How do we express Charles' law mathematically? It's very simple. Mathematically, Charles, according to him, he said that volume is directly proportional to absolute temperature in Kelvin, provided pressure is kept what? Constant. And because of this, we now say that, okay, well, V will be equal to what? Your KT. I've removed proportionality to bring in constant K. If V is equals to KT, make K subject of the formula. It means that I'm going to divide here by T. If I'm making K subject of the formula, I'll divide here by T as well. T will come and cancel what? T. When that happens, what is your K? K is equals to what? Your V all over what? T. If K is equals to V all over T, the question is, okay, what if I have two separate gases that I'm dealing with? It means I'm going to have your V1 all over my T1. What will it give me? Your V2 all over your what? Your T2. Your V1 all over T1 is equals to V2 all over T2. Which law is this, everybody? This is your what? Your Charles' law. Your V1 all over T1 is equals to V2 all over T2. Which law is that? Your Charles' law. Very quickly. To get that very fast, look at this. Jamb 1981 question 30. So when it comes to creating an account, right? This is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this. As a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you are putting your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for Jamb or Waec. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and Waec, click Waec Jamb Pursuit TME, right? As the select education. Select level. You are not preparing for Pursuit TME, you are preparing for Jamb and Waec, right? Okay, click on the what? Jamb and what? Waec. And then create your account. 2 seconds. Plus, you don't enter. It will load and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do you do? Start learning. Jamb brought this powerful question that says 28.8 cm cube of nitrogen at 15 degrees Celsius is cooled to 0 degrees Celsius at constant what pressure. Because pressure here is constant, you should just know that that's Charles' law for you. The question says the new volume of nitrogen is, that's the question. What's the new volume of nitrogen? Very fast. Yeah, let's go. First and foremost, this is your volume there, V1. So that first volume they have given us, that's your V1, is 28.8 cm cubed at 15 degrees Celsius. And again, don't forget that your T1 was given to be what? 15 degrees Celsius. But according to Charles' law, you must solve everything in what? In Kelvin. Absolute temperature is in Kelvin, not in Celsius. So for me to convert 15 degrees Celsius to Kelvin, what is it going to give me? It's going to give me 15 plus 273, right? For me to convert it to Kelvin. And that's going to give me what? 288 Kelvin. That's what I'm going to have there, 288 Kelvin. Now that I've gotten 288 Kelvin, the question says, if the volume, this volume, that's 28.8 cm cube of nitrogen at 15 degrees Celsius is cooled to 0 degrees Celsius. That means your T2 now, right, is 0 degrees Celsius because you are moving from 15, you are cooling it to 0 degrees. In fact, I don't even need to go far. Because you are decreasing temperature, right, according to Charles' law, what will happen to volume? Your volume will decrease. Our answer is going to reduce. So the answer is not going to be up to 28.8. No, anything higher than that, you are wrong. It shouldn't even be up to that. Now, 0 degrees Celsius, convert it to Kelvin. That will give you 273 watts Kelvin because 0 is 273 Kelvin, right? Simple. From this now, what is your V2? Your V2 is equal to what? Unknown. So according to Charles' law, your V1 all over your T1 is equal to your V2 all over your what? Your T2, right? Yes, very, very simple. So from here now, what can we deduce? What's your what are we looking for? V2. So your V2 is equal to your what? Your V1 T2 all over your what? Your T1. And from there, what can we solve it to be? That means your V2 is equal to what's your V1? V1 is 28.8 times your T2. What's your T2? T2 is your 273 divided by your what? Your 288. So if I use calculator, take your calculator and then press your 28.8, right? You know, Jamb is just normal calculator, your market women calculator that you have in your Jamb interface, right? So you just use it for the calculations quick. 28.8 times your 273 divided by your 288. What is it going to give you? That's going to give you 27.3. So the answer there automatically will give you 27 point what? Your 3 in what? In your cm cube. This become the what answer. So what are we looking for? 27.3 cm cube. So where do we have 27.3 cm cube? Option A. Can option A be the answer? No, it is not option A. Option B, 14.7. No. Option C says 27.3. Hooray! Option D, never. That's not the answer. What is the answer? Option C become the answer. Very simple, very easy, cheap and direct. You are out of there. If you get that very fast, we are rush and solve this question for me. Jamb 1992 question 5. Look at the powerful question under Charles' law. A given mass of a gas occupies your what? Your 2 dm cube. A given mass of a gas occupies 2 dm cube at 300 Kelvin. They have given you volume, they have given you temperature. What's the volume from there? Volume is 2 dm cube. You don't need to convert dm cube to cm cube. The only thing you should bother yourself about in Charles' law is that your temperature is in Kelvin. That's all. That means your V1 is that 2 dm cube, right? Yeah. And then they gave T1 to be what? What's your T1? 300 watts Kelvin, right? The question says at what a given mass of a gas occupied 2 dm cube at 300 Kelvin. At what temperature? At what temperature? That's your T2. We don't know it. Will the volume be doubled? That means your V2 now is double of your V1. That's going to give you 2 times 2. And what's 2 times 2? In what? Dm cube. That's what they are saying there. That's going to give you 4 dm cube. The question is saying, at what temperature will the volume be doubled? Keeping pressure constant. Very simple. So you are looking for your T2 from there. Don't forget that according to your Charles' law, right, your V1 all over your T1 is equal to your V2 all over what? T2. What are you looking for? You are looking for your what? Your T2. Therefore, make T2 subject of the formula. What's your T2 from here? T2 is going to give you nothing but your what there very fast. Your V, that's your T1 V2 all over your what? Your V1. That's what you're going to have there. Oh yeah, let's compute in our figures and then solve and see. What's your T2? T2 is equals to T1. T1 is 300 times your V2. What's your V2? 4 divided by your V1. That's your 2. 2 here, 1. 2 here. How many am I going to have there? That's your 2. 2 times 300. That's your what? Your 600. 600 what? Kelvin is the temperature. Very simple. This guy has just obeyed Charles' law. Look at it. They gave you your volume as 2. They now double the volume to 4. You don't even need to solve. If temperature is 300 here, you know, according to Charles' law, your volume is directly proportional to temperature. That means as volume increases, temperature increases. As volume doubles, temperature doubles. If volume is 2 and it has doubled to 4, if temperature is now 300, what will it double to? 600. That's the answer. Are you seeing it now? So let's check the one that is 600 in the option and then let's pick our answer. Option A is 400 Kelvin. No, we are looking for 600. Option B says 480. No. Option C says 550. No. Option D says 600. Hooray, what is the answer? 600 Kelvin. Option D is the correct answer. Does it make sense? If you get this very quickly with me and you are very sure that you understand it, bro, guess what? What is it about absolute temperature? So you see that absolute temperature, we call it absolute zero temperature. So what is it about absolute zero temperature in your chemistry or your physics calculations? What should we know about it? It's very simple. Don't forget that absolute zero temperature is the lowest temperature, the lowest. See, in fact, the lowest of the lowest that is thermodynamically possible. Right? The lowest temperature that is ever possible thermodynamically is called your absolute zero temperature. And don't forget is that it is the temperature at which the volume of a gas is theoretically reduced to zero. Volume of a gas, wherever the volume is, at what temperature is it reduced to zero theoretically? Absolute zero temperature. Very interestingly, don't forget that at absolute zero temperature, what happened? A gas has no kinetic energy. Number one, at absolute zero temperature, a gas will have no kinetic energy. A gas will have no velocity. That's number two, no velocity. Number three, it will exert no pressure on the container. Give me the three characters you should see in your absolute zero temperature. No kinetic energy, no velocity, no pressure is exerted on the walls of the water container because the volume has been reduced towards zero. And don't forget this, that the value of absolute zero temperature is minus 273 degrees Celsius. Minus What is the value of absolute zero temperature? It's a constant exam question. Minus 273 degrees Celsius. Or what? 0 Kelvin. If it is in Kelvin, it is 0. If it is in Celsius, it is minus 273 degrees Celsius. Why? Because minus 273 degrees Celsius is the same thing as your 0 Kelvin. And because it is absolute temperature, it must always be in Kelvin. 0 Kelvin. 0 Kelvin, right, is equal to what? Minus 273 degrees Celsius. If you feel on, look at the question now. This question was asked in Jamb 2004 question 41. The question all the way says, according to Charles' law, the volume of a gas becomes zero at option A says 100 degrees Celsius, B says minus 273 degrees Celsius, C says 373 degrees Celsius, D says 0 Celsius. What is the answer? What is the value for your absolute zero temperature? That's what they're asking you there. It is what? Minus 273 degrees Celsius or 0 what? Kelvin. That's the answer. And which option correlate to that? Option what? B is the correct answer. What is option B? Minus 273 degrees. Don't go and choose 273. Oh. No, minus 273. Or don't go and choose 0 degrees Celsius. No, it is 0 Kelvin, which is equal to minus 273 degrees Celsius. Does it make sense? If you get this very fast with me, please, what is the graphical representation of your Charles' law? How do we represent Charles' law graphically? Don't forget this. Charles' law is represented graphically in three ways. Any of these three cases, I gave you three cases of your Boyle's law. You remember them, right? Yeah. So what are the three cases that you see in your Charles' law? Very simple. Case one. Yeah, let's go, guys. It's possible that you see something like this. Very, very easy and direct. What's that? Come. This guy is volume in cm cube. And this guy is temperature. I told you, if you see a graph like this, right? What's that? Directly proportional. If it like, oh, it should come and be like this, so what is it? It should come and be like this. That's it, directly proportional. Now, what is happening here? Your volume is directly proportional to temperature. That means volume is directly proportional to what? Absolute temperature. Whether they like, they should put the temperature in degrees Celsius. You can also convert it to what? Kelvin. You know that already, right? Yeah, sure. And look at this. Here now is minus 273 degrees Celsius. That's what I want you to pay attention to. Minus 273 degrees Celsius there. Because we have minus 273 degrees Celsius there, it will ring something in your mind. Absolute what temperature is what? Minus 273 degrees Celsius, or what? Your 0 Kelvin. Does it make sense? So this is your case 1, how it presents itself. Now look at it well again. This is how it presents itself. So if you see anything of this nature, just check. Is it volume against temperature, and then straight line graph like this? Haha, directly proportional. You're out of the Charles law. Case 2. How does it present itself? Still like this. But now something has changed. The air is no longer what? Minus 273 degrees Celsius. I told you that minus 273 degrees Celsius, right, is equal to what? Your 0 what? Kelvin. And that's your absolute 0 what? Temperature. Of course, you can see that here is your volume in your cm cube, and then here is your what? Temperature. Volume is directly proportional to what? Absolute what? Temperature. That's your what? Charles law. That's case 2. So whether you see 0 Kelvin there or minus 273 degrees Celsius, so it's the same thing. And case 3, very fast. How does it present itself? It is like this, direct. Here is 0. This origin now, 0 there is telling us that that's the origin, right? You have your x and your y-axis where they are meeting. Here's your y-axis, here's your x-axis, right? Ordinate and abscissa. Where they are meeting, here like this is the origin, and that's your what? Your 0. And then this guy is going up like that. Of course, your volume, this is telling us that volume is what? Directly proportional to absolute what? Temperature. And what's that? Charles law. That's it. So these are the 3 powerful cases in regarding your what? Your graphical representation. If you get that very fast, no stress. Will come and answer this question for me. Now that you have created your account, right? For you to start learning, what do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized. They are all there for you, right? What do? Okay, I want to start learning biology. So click on the biology. Immediately you click on it. Living organisms. That's chapter 1, right? Oh yes, that's strictly to your Jamb syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it. Immediately you click on it, you see all the classes will display. History of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cell immediately. Hello, friends. Your class will start playing for you. It's easy and it will start playing for you easy and direct. And what happened? You can even choose to make it full screen. Right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use Nightsub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start what? Loading. As it start loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following. The answers are there. Number 1 answer is B. Why is the answer B? It is explained for you in details. Every singular thing. And then you are following your classes. You are done with that. You come to the next. You see your notes. Everything structured and organized. to the core. In fact, at the end of the day, there is a blow kiss for you. Mwah, you have done well. Get out, you too much. Everything is structured and organized for you in the app, right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and purification. All of them are in line with your JAMB syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the what? Order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down right on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right? Or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your WAEC cell or the JAMB question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosomal. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your JAMB 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
JAMB 1988 question 6. From the diagram, you don't need to go far. You are seeing your volume, cm cube, temperature, volume and temperature. Something should hit you. And the question on the way says, which of the gas laws does the following gas illustrate? Volume is directly proportional to what? Temperature. What's that now? Is it your Boyle's law, or it is your Charles law, or it is your Graham's law, or it is your Gay-Lussac's law? What's the answer? Of course, it is nothing but your what? Charles law. Option B is the answer. You're out of there. Wait. No stress. Does it make sense? Look at the next question very fast. JAMB 1988 question 6. They brought this powerful question all the way. Say the graph above illustrates. What does it illustrate? Your volume here, and here is your what? Your temperature. What does it signify to us? It means that your volume is directly proportional to temperature, and that's your what? Charles law. The graph above illustrates. What does it illustrate to us? Option A says Charles law, B says Boyle's law, C says your Gay-Lussac's law, and then this is Graham's law. What's the answer? Of course, it is nothing but your what? Your Charles law. Option A is the answer. But please look at it. In your Charles law, yeah, like this, what is it? It is minus 273 degree what? Celsius, which is equal to what? 0 Kelvin. Don't forget that, right? So you can see that you just cut JAMB, red-handed JAMB. Now make one slide, that's. So you are feeling it now. If you understand that very quickly with me, another thing very fast is the explanation of Charles law using kinetic theory. So how do we use kinetic theory to explain and validate your what? Your Charles law? It's very simple. There are two major things there. Number one way we can use that is if the temperature of the gas molecule is increased. How do you increase temperature of gas molecule? By heating the gas. You have a gas, you want to increase the temperature, you heat the gas, you increase temperature. At what? Constant pressure. We can use this to validate your kinetic theory. Or if the temperature of the gas molecule is reduced, you reduce the temperature of the gas molecule by cooling it at what? Constant what? Pressure. Any of these two can validate your kinetic theory. Let's start with the first. If the temperature of the gas molecule is increased, it's just like, for example, you carry gas now and you are heating the gas at constant pressure. How do we achieve this? I want you to open your 5 senses. Open your mind. Understand this quickly with me. Number one, please take note that as you increase temperature, anything I make you to increase temperature, what will happen? As temperature increases, the average velocity of the gas molecules will also increase. Picture your gas in container. As you are increasing temperature, what will happen? The velocity of the gas, average velocity is increasing. And because average velocity is increasing, it will go and affect kinetic energy. That's why the average kinetic energy of the gas molecules will also what? Increase. And because the kinetic energy is increasing, what will happen? The molecules of the gases, they will begin to move what? Faster. As they move faster, it will lead us to the next thing. The frequency of their collision, right? Of the collision of the molecules with themselves and with the walls of the container will increase. Now look at it. You have increased temperature. Because you increase temperature, what will happen? Average velocity of the what? Gas molecules will increase. So the molecules are now warming up to start to move faster. As they're moving faster, they acquire kinetic energy. The kinetic energy that they are gaining there because of the increased temperature will make them to move faster. And because they are moving faster, the frequency of the collision of the gas molecules with each other is increasing. And as a result of that, what will happen? The bombardments of those gas molecules with the walls of their container will also increase. And as a result of that, what we develop from there? Pressure. We start to build up. So pressure will what? Increase. But now look at it. According to your Charles law states that volume is directly proportional to temperature at what? Constant pressure. Now pressure is increasing, but we want to keep pressure constant. That's why we say that if the volume of gas molecule is increased by heating at constant pressure, we want pressure to be constant so that we can obey Charles law. What do? It's very simple. What you need to do is this. To maintain constant pressure, simple thing, increase the volume of the container. Increase the volume of the container, you will maintain pressure. Oh, look at this very fast. From here, look at it now. As I begin to hit this, your gas molecules here, what will happen? As I hit them, the velocity of the gas molecules will begin to increase. As the velocity increases, they will acquire kinetic energy and begin to move faster and collide with each other and with the walls of the container. Pressure will begin to build. As pressure builds, what will happen? I want to maintain pressure. I don't want an increase in pressure. Because I don't want an increase in pressure, rather what will I increase? I'm going to increase the volume of the container. That's all. Just increase the volume of the container. As volume increases, according to Charles law, temperature also increases. Or as temperature increases, first you have altered the temperature of the molecules here. And because you have altered the temperature, for you to keep it at constant pressure, you need to go and alter the what? Your volume. That's why volume here has to do what? Increase. So according to Charles law, if you increase temperature, what will happen? You need to increase volume. Or as you increase volume, you need to increase what? Temperature, and vice versa. Does it make sense? So period, that's the first case. The second case here, very fast, is where you have to reduce temperature. So what happens here? If the temperature of the gas molecule is reduced by what? Cooling. As you reduce the temperature by cooling, and then you want your pressure to be constant, what happens there? Now listen. First and foremost, we are going to decrease temperature. So as I am decreasing temperature of the gas molecule, the quick question is what will happen? As you decrease temperature, don't forget this, that the average velocity of the gas molecules will decrease. You are cooling the gas. You are decreasing the temperature. The average velocity will begin to decrease. As their velocity decreases, the molecules will begin to move slowly. They are not moving faster. They are going to move slow. As they move slowly, what happens? The frequency of the collision of the molecules with each other will reduce. The frequency with the walls of the container will reduce. And as a result of that, what will happen to pressure? Pressure is going to fall. So pressure will what? Decrease. So as pressure decreases, what happens? We don't want pressure to decrease here. We want to keep pressure constant. Because you are decreasing temperature, right? And you want pressure to be what? Constant. What will you do to the volume? You have to do what? Very quickly. You have to decrease the volume of the container. Simple thing. Look at the container here. This is the container. I am cooling this down. I am decreasing temperature. As I'm cooling it, what will happen? The velocity of the gas molecules will begin to what? Move slowly. Kinetic energy will be slow. Because kinetic energy is slow, what will happen? Pressure will fall. And because pressure falls, what happens? I want the pressure to be maintained. I don't want to reduce or decrease the pressure. What do I need to do? It's very simple. This volume here is high. And because the volume here is high, the only thing I have to do is go and reduce the volume there. So, according to Charles law, it's very simple. As temperature decreases, how is it going to relate to volume? You need to decrease your volume as well. That's what Charles law is telling us. So, is it okay, sir, to say according to Charles law, your temperature right? Absolute temperature in Kelvin is directly proportional to volume. Yes. Or volume is directly proportional to what? Absolute what? Temperature. That's what Charles' law is telling us. Just understand these guys. Look at this question very quickly. WAEC 2002 question 9. The question of the way. Let's go. According to Charles' law, what happens to the volume of a gas when temperature is decreased? According to Charles' law. And now look at it now. Volume is directly proportional to what? Temperature. According to Charles' law, when you decrease temperature, what will happen to volume? Volume will decrease. That's it. Option A says volume increases. No, sir. Option B says volume decreases. Yes, sir. Option C says volume remain unchanged. Never, sir. Option D says it fluctuates. No. What is the answer? Volume will do what? Decrease is the answer. Option B. Period. You're out of there. Does it make sense? If you get this and you understand it very, very well, guess what? That's everything about Charles' law that you need to know. And again, what is constant in Charles' law is what? Pressure. Is what? Constant in Charles' law. And because pressure is constant in Charles' law, is it okay? You know, I told you that temperature is constant in your Boyle's law. Because temperature is constant in Boyle's law, we said that Boyle's law is what? Isothermal. Isothermal. Now, in your Charles' law, pressure is constant. Pressure is isobaric. 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 So your Charles' law is isobaric because pressure is constant. Boyle's law is what? Isothermal. What is constant there? Temperature is what? Constant. If you get this very fast with me, bro, guess what? I'll see you in the next class. And in that next class, we're going to look at the applications of Boyle's law and your Charles' law. But please, for the now, I beg you, go to my notes. Right? There are questions under Charles' law. Only you go there, go and solve all of them. Hope you have solved all the questions in your Boyle's law. After every teaching, go to the notes. All of them have their own individual notes. Go and solve all the questions under your Charles' law and get all the answers as far as Jamb And Waec is concerned. All of them, the answers are there. Go and solve them very fast. And also, practice CBT. There's past question segments of the app. Always practice, always practice, always practice. And very importantly, tell a friend about the LearnLift app. Tell somebody about the LearnLift app today. I'll see you in the applications of your Boyle's law in the next class. For the now, peace out. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.